Let's do a little bit of disorder modeling. The structure I'm looking at is in the disordered folder in the Jaca folder, and I'm getting it. Here we are. To solve it, just type solve, and we have the structure on the screen. Refine, and we have some problem here. We can see that these oxygens are quite big already. Make it anisotropic, just type anis and refine, Ctrl R. So Ctrl M clearly shows there's something not right. So this oxygen is currently a fully occupied oxygen atom. This is this, but it really doesn't want to be this. This is lighter. So we assign too much electron density here. So we also know from the formula that the chemist expected some fluorine here. So the suspicion is that these are really two partly occupied fluorines. So one here, and then there's a hydrogen here, and the other one here, and then there's a hydrogen over here. So it's rotated around this bond. Now the way to do this quite quickly is to just name both of those fluorine, name F. And this one is the one that was more highly occupied, so I'm going to call this part 1. I'm putting it into the first part, and I'm giving it a link code of -21. So it's the leading part, 21. Part 1, 21. Now this is cryptic. Just go with it. Yeah, so you automatically type this very quickly. Part 1, 21. And that's now the part 1. And this one then will be part 2, and it's -21. The -21 means it's linked to the first one. So the sum of these two occupancies will always be 1. So this is linked through a free variable in the original Shellick system, and in Ulrich to Refine we've taken that same concept. So it's a free variable linking mechanism. Don't worry about it too much right now, but the syntax is part 1, 21, part 2, -21. And if we put that in, we can hit Ctrl R, refine this. The R factor goes from 7.48%. No, it's still down here. Sorry, it was higher before. We haven't got hydrogens yet, so we add the hydrogen atoms to this. And you notice Ulrich 2 added 2 hydrogen atoms here as well. So the R factor is now very, very much better. We do have a goodness of fit that is quite high. And remember, that is the... Wait, we haven't switched weighting scheme on yet. Let's also switch the actor on at some point, and let's refine this. So this is actually a nice example of, you might say, oh, the R factor is 4.82%, we are done. But if you don't press Ctrl M, you might miss something. So up here, first of all, that hydrogen really isn't there. And in fact, this whole thing is green. So that means we want more electron density in that region. And that's because that is really a fluorine and not an oxygen. And you can also see this from the formula that was expected. We have 3 oxygens. We already got 3. That's a fourth. We got 2 fluorines. We got 2. No, we don't. We don't have 2 fluorines. We've got 60%, 61% of one fluorine, and then the 40% or 39% of the other fluorine. So those two add up to one fluorine. If you don't believe me, select both and type info. And that gives you somewhere here the occupancy, the chemical occupancy is exactly 1. So it's F1 down here. So this thing up here, that hydrogen doesn't exist. That thing here, name F, is really a fluorine atom. And hopefully the R factor will drop somewhat more. It has. And Ctrl M also shows me that this is much cleaner. However, there's a little bit of an issue here. All the stuff here is just red, so there is no green. That should be balanced. There's a nice little tool here in the reflection statistics. You can look at the fractal dimension plot. It also prints a reference to that plot, and you can read up on it. It's really quite useful, and that tells us there is really quite a lot too much on this side. So this should be, that should be mirrored on that side, and it should be all symmetrical, and it isn't. So something isn't right, either with the model or with the data. In this case, what it is quite visible if we click on this. So there is quite a bit of stuff going on. It's diverging here. And it may be, I don't know whether this, I don't know why this is. I have no idea of the history of these data. But you could try refining extinction, and also the weighting scheme hasn't settled yet. So we need to do this a few more times. And hopefully this will become a little bit more balanced. 4.19, 3.93. So this really has come down a fair bit on here. So we're still not green. Let's refine this one more time, and hopefully now this should be all settled. This now, it's still got that fanning out here. So some of those strongish, fairly strong reflections, so this will be low index 210. So this one is observed lower than what we expect, and these two are observed slightly higher than we would expect. So there could be a number of reasons for this, but hopefully the map is a little bit, it shows a bit of green, so this is a bit more encouraging. And also, of course, the scale here is that overall level is very, very low, so there's nothing to worry about it here, but it's worth keeping this in mind to check out at the end whether you've done your weighting scheme and the extinction. So this is 0.023 with an ESD of 3, so there's plus or minus 3 in the last digit, so that's okay, it's valid, it's a thing we do want to refine. Another little check you can do in the bad reflection, so if there's anything that stands out as being really bad, reflection that has been under the beam stop, you can omit that from here, but there is nothing going on here. So I think this is pretty much a finished structure, and thanks for using OLX2.